All right, 4.4, day 1, exponential and log equations. And so our objectives for this part are we're going to use like bases to solve exponential equations. We're going to use logarithms to solve exponential equations. And we're going to use the definition of a logarithm to solve logarithmic equations. All right, so solving exponential equations by expressing each side as a power of the same base. It says if b to the m is equal to b to the n, then m equals n. So first thing we're going to do is we're going to rewrite the equation in the form of b to the m equals b to the n, set the exponents equal to each other, and solve for the variable. And so we did this on some of the others when we had like 2 to the x equals 8. And remember we said, can we get 8 down to a base of 2? And we had said yes, the 8 was 2 to the third. And so we had 2 to the x equals 2 to the third. And we got rid of the bases, or we didn't really get rid of them. We just were able to ignore them because our exponents had to be equal. That's the same exact thing here. Now we may be stepping into where it's not just will 8 go down to a base of 2, but will both of the bases go to the same base? But we'll look at that when we get there. All right, so example 1 here. On A, solve 5 to the 3x minus 6 equals 125. Again, can 125 go down to a base of 5? Yes, it can. 125 is 5 to the third. And so I'll bring down the other side. So 5 to the 3x minus 6 equals that 5 to the third. Your bases are the same, so you can ignore them. So that means that 3x minus 6 has to equal 3. And then we're just going to solve for x. So we're going to add the 6. So we get 3x equals 9. Divide by that 3. And we find x equals 3. Now we're going to do the same thing on B, but on B we encounter a different problem here. So on B we want to know, can the 8, because it's the bigger one, go down to a base of 4? It cannot. So then we have to ask ourselves, will 8 and 4 both go down to some base? Well, they both go down to a base of 2. 8 is just going to be 2 to the third power, and then we're going to put that x plus 2. Equals, and 4 is 2 squared, and then we have our x minus 3. Now remember, these exponents are side by side up here, which means we're going to multiply, and our bases are the same, so we can just ignore them. So we have 3 times x plus 2 equals 2 times the x minus 3. And then we're just going to solve this for x. So first thing we're going to do is we're going to simplify each side. So I'm going to distribute this 3. I'm going to distribute this 2. And then I can't simplify each side anymore, so now I'm going to start getting my x's on one side and my non-x's on the other. So I'm going to subtract this 2x. So I have x, bring down your plus 6, equals, bring down your negative 6. And then subtract the 6 over. And so we get x equals negative 6 minus 6 is negative 12. And so we've solved our equation there. All right, but sometimes we can't get like bases at all. And when we can't get like bases at all, then we're going to have to use logarithms to solve it. So the first thing we're going to do is isolate the exponential expression. So you want that b to the y, you want that base and that exponent by itself. Then you're going to take the common log on both sides of the equation for base 10. Take the natural logarithm on both sides of the equation for bases other than 10. Simplify using one of the following properties. So basically you're going to change b to the y equals x and log base b of x equals y, whatever we need, and then solve for the variable. So let's try this. So 5 to the x equals 134. First, I always check, can 134 go down to a base of 5? I don't think so. Can 134 and 5 go down to the same base? Again, I don't think so, because 5 is prime. It's not going to go any lower. So we're going to have to take the log, or the natural log, of both sides. And so it doesn't matter which. I'm going to go ahead and I'm going to do the natural log. So we're going to have the natural log of 5 to the x equals a natural log of 134. And then remember, we can get the x out of the exponent using that power rule. So this x times natural log of 5 equals a natural log of 134. And then we can solve for x by dividing by that natural log of 5. And so we get x equals, and then we're just going to type that in our calculator. All right, so I typed natural log of 134 divided by natural log of 5, and I got 3.043. Now, if we would have taken the log of both sides, we could have done that, and our answer would be exactly the same. All right, so 10 to the x equals 8,000. Again, can I get 8,000 to a base of 10? I really don't know. That's going to be hard to figure out. I don't think so, since it didn't start with a 1. But I know that I can use logarithms to solve. And so I can use the common log, or I can use the natural log. It doesn't matter which. So since I did the natural log before, I'm going to do common log on this one. So just as long as what you do to one side, you do to the other. So I'm going to log both sides. And then just like on the other one, I'm going to use that power rule to move that x out of the exponent. And then we're solving for x. It's x times that log, so we're going to divide by a log of 10. And so x equals, so my calculator, I'm going to type in log of 8,000 divided by log of 10. And I got 3.903. All right, example 4. Can I get 7 down to a base of 3? I cannot. So I'm going to log both sides. And I'll use the natural log again. Why? Because I picked it. I don't know otherwise. So I'll take the natural log of the left side equals the natural log of the right side. And then both of these have x in the exponent. So I'm going to use that power rule. Now be careful, because that 2x minus 1 is in the exponent together. Let's keep it together here. And the same thing over here. We're going to use the power rule to put it in front of its log, but it's together in the exponent, so keep it together in parentheses. All right, now it's up to you. At this point, we could go ahead and use some decimals if you want. We can find the natural log of 3 and the natural log of 7. Change those to decimals. I think that might be our easiest. So I'm going to rewrite this one real quick. I'm going to put my natural log first. I got the natural log of 3 times 2x minus 1 equals, and I'm going to do the same thing over here, because remember, multiplication, the order doesn't matter. So natural log of 7 times x plus 1. And then I'm going to go type the natural log of 3 in my calculator. Now, if you're using a logarithm, your number is going to be different, but our answer at the end will come out to be the same. So I've got 1.0986 times 2x minus 1 equals, I'm going to type natural log of 7 in my calculator. And I got 1.9459 times x plus 1. And so I'm just going to go through here, and I'm just going to algebraically simplify each side, and then I'm going to solve for x. I'm going to distribute this 1.0986. So 1.0986 times 2. So I got 2.1972x. And then 1.0986 times negative 1 is negative 1.0986. Then I'm going to take the 1.9459 times x. So 1.9459x. And 1.9459 times 1 is positive 1.9459. Then I need to get my x's on one side, my non-x's on the other. So I'm going to move this 1.9459x over by subtracting it. So 2.1972 minus 1.9459. I got 0.2513x. Bring down your minus 1.0986 equals, that canceled. Bring down the 1.9459. So I got my x's on the left, so I'm going to move this non-x over here back to the right. So I'm going to add it. So I got that 0.2513x, that cancels, equals 1.9459 plus 1.0986. So 3.0445, and then divide by the number in front of the x. So we're going to divide by 0.2513. So we'll get x equals and if I typed it in right, I got 12.115. Now this is approximate, okay? If you round it to less decimal places, you're going to have your number's going to be off more. If you round it to more decimal places, then your number will be more exact, okay? If you waited to the very end to type your natural logs into your calculator, then your number's going to be even more exact. So this is just a good approximate. So you should have approximately 12.115. Okay, using the definition of a logarithm to solve logarithmic equations. So it says the first thing we're going to do is express the equation in the form of log base b of m equals c. Then we use the definition of a logarithm to write the equation in exponential form. So change it to b to the c equals m. So basically, if it's in log form, we're just going to change it to our exponential form. I know they changed the variables on us some, but it's still that b to the y equals x. It's no different. They just put m and c. Then we're going to solve for the variable. But then number 4 here is super important, okay? Because our original equation starts with a log, we have to check the proposed solutions in the original equation. Remember that when we talked about the graphs of logs, we said that the domain, because of the way they were graphed, it looks like this. And remember we have let me change colors here, we have a vertical asymptote right there. We'd said our domain was where that x was greater than 0. So whatever value we get, we've got to plug it back into this piece right here to make sure that when we work that out, that number is going to be greater than 0. If it's 0 or a negative number, then our solution doesn't work. All right, and so we'll see that in practice here coming up. All right, so we got log base 2 of x minus 4 is equal to 3. I don't have a log equals a log like we did back in like 4.2, I think it was. So we're in log form and we're stuck. So let's just change it to exponential. So remember we're in log form. So log base b of x equals y. And we're going to change it to exponential. So b to the y equals x. All right, so my base is 2. My x is the x minus 4. And my y is 3. So I'm going to go to exponential. I have my b to the y equals x. Well, 2 to the third is 8. So 8 equals x minus 4. Solve for x. So add the 4. And we get 12 equals x. Now, before we can say that's our answer, we got to go back up here and look at that x piece. When I plug in 12, will it work? So what is 12 minus 4? It's 8. And because 8 is greater than 0, we know that 12 will work, so our answer is 12. If we were to come up with 0 or a negative number there, we would have a no solution. So let's try it again here. So I've got 4 times the natural log of 3x is equal to 8. Well, something to be careful of is this isn't in log base b of x equals y. We've got this number in front. But remember that power rule says we can move it back as the exponent. So, oops, you know what? Actually, let's do this first. It's 4 times the natural log of 3x. Let's actually divide by 4. That would be even better because we don't want to deal with exponents. So we have that natural log of 3x equals, and 8 divided by 4 is 2. Now we have the log by itself. I can't do anything else, so let's change to exponential. Because remember that natural log is just log base e. So I'm going to rewrite this. And now I can see that my base is e, my x is the 3x, and my y is 2. So when I set it up into exponential, I get b to the y equals x. I want to solve for x, so divide by that 3. And so we get e squared divided by 3 equals x. Now we could put that in the calculator and it's going to give us a decimal. But we can leave it as e squared divided by 3 if we want to. But now we do have to come back up here and we have to check this. And so I'm going to write it over here. So I have 3x. And so this is 3 times e squared over 3, because that's what we said our x was. Which when I simplify that just gives me e squared. Well, remember e is approximately 2.7 something. And so if I square that, it's going to get even bigger. So it's going to stay positive. So therefore, my answer works. All right, on example 7 here, we have log of x plus log of x minus 3 equals 1. Well, we're not just in log base b of x equals y form here, but I do have 2 logarithms, and so I can combine them. Remember, if they're being added, we can combine them with multiplication. So we got log of x times x minus 3 equals 1. And I'm just going to go ahead and distribute that x inside there, clean it up a little bit. So we got x squared minus 3x inside. And now I do have a single log. Remember, what is its base? If it says log and there's no base written, it's automatically a 10. So we know our base is 10. Our x is x squared minus 3x. And our y is 1. So when I put this in exponential form, I have b to the y equals x. Well, 10 to the first is just 10. And so I have 10 is equal to x squared minus 3x. Now remember, anytime you have an x squared and an x term, that means we're going to need to factor. In order to factor, our equation has to be set equal to 0. So I'm going to move this 10 over. So I have 0 equals x squared minus 3x minus 10. And so it's 3 terms, so this is where we did our box and our table. So let's see. So I'll do our box up here. So we know it's going to have x squared. It's going to have minus 10. And then we had our table, remember? We're going to take our first times our last, our a times c. So 1 times negative 10 is negative 10. So they've got to multiply to negative 10. And then they have to combine to be b. And in this case, our b is a negative 3. So let's see. We got 1 times 10, 2 times 5. So we know to combine to get a 3. The only way we can do it is a 5 and a 2. And they got to be opposite signs to be negative 10. And 5 is going to need to be bigger. Try that again. 5 is going to need, it's a bigger number, so it needs to be negative. So I'm going to have a negative 5 and a positive 2. So a negative 5x and a positive 2x. Remember, it doesn't matter which one is which. And then we're going to common factor each row in each column. So starting right here, this row has an x in common. This row, I can take out a positive 2. Remember, you always take the sign of the number right beside it. All right, then I'm going to work on my columns. So this column right here, I can take out an x, and this column, I can take out a -5. Negative, because that's negative, and 5 and 10 are both divisible by 5. So I found my factors there to be x plus 2 times x minus 5. And then remember, this whole thing was equal to 0. And then we set them each equal to 0 and solve. So x plus 2 equals 0, x minus 5 equals 0. Subtract the 2, so x equals -2. Don't box it yet. Add the 5. So x equals 5, and don't box it. Because we started out with log, we've got to check our answers. So when I check this -2 here, I'm going to come up here, and can I take log of -2? No, I can't take log of a 0 or a negative number, so -2 does not work. But I have another answer choice. If I didn't, I would just say no solution, but we still have that 5, so let's check that 5. So when I check it in this first log function, log of 5, that's okay. When I plug in the 5 here, I got 5 minus 3, which is 2. That's still positive, so it's okay. So x equals 5 is a solution. If the 5 had not worked, then neither solution would work, so we'd put no solution. But as long as one of them works, that's our answer. All right, and that's the end of day 1.